let's discuss with the determination of primary structure of protein. Primary structure is the linear sequence of amino acids forming the backbone of proteins. Determination of primary structure, it includes the identification of constituent amino acids along with their quality, quantity and sequence in the protein structure. A pure sample of protein or a polypeptide is essential for the determination of primary structure, and it involves 3 stages. First step is determination of amino acid composition. In this process, the protein is completely hydrolyzed to liberate the amino acids, and then these amino acids are quantitatively estimated by using chromatographic techniques. While the second step is degradation of protein or polypeptides into smaller fragments. Protein is a large molecule which is sometimes composed of various polypeptide chains. Separation of these polypeptide chain is essential before degradation, and from that the number of polypeptides present in the protein can be determined. The third step is the determination of the amino acid sequence. This is one of the most important step in the determination of primary structure of protein. For this step, various chemical methods are used. Now we will discuss some chemical methods which are used in the determination of primary structure of protein. The first method is a Densyl chloride method. Now, Densyl chloride, it is by using the Densyl chloride, the number of polypeptide chains can be identified. Whether there are 50, 70, how many number of polypeptide chains are present, that can be determined by using the Densyl chloride. Now see this reaction. This is a Densyl chloride. Here this is a naphthalene structure. At first carbon atom, N dimethyl group is attached, and here sulfonyl chloride is attached. So this complete structure is called as Densyl chloride. When this Densyl chloride, it specifically bind with N-terminal amino acid. I told you that this side is called as N-terminal and this side of amino acid is called as C-terminal. So Densyl chloride through this chlorine attach with the N-terminal amino acid to form Densyl polypeptides. So here this chlorine and hydrogen from NH2, they are removed, and this NH group is attached to the SO2. So what we are getting, again see this structure remain as it is, while chlorine from SO2 is removed, and here NHCH R1CONH, this polypeptide chain is attached. This polypeptide chain on hydrolysis, it gives the here N-terminal amino acid only attached with this sulfonyl group, while remaining amino acids become free. So from the number of N-terminal Densyl amino acid produced, which is equal to the number of polypeptide chains. So by using this method, how many polypeptide chains are present in the protein, that can be identified. Next method, it is a Sanger's method. In this Sanger's method, FDNB See here, this is benzene ring. Fluorine, it is at first position, and at second and fourth position nitro groups are there. So it is called as 1-fluoro-2,4 dinitrobenzene, that is FDNB. It bind with the N-terminal amino acid. Here again you can see this fluorine and hydrogen is removed, so that this NH group is attached to the benzene ring, and here we get N-terminal amino acid derivative of DNP, which on hydrolysis give 2,4-DNP derivative of amino acids and free amino acids. Again, this help to identify the number of amino acids present in the polypeptide chain. Next method or next reagent which is used, it is the Edmund reagent. This Edmund reagent, it is nothing but the phenyl isothiocyanate. Phenyl isothiocyanate is also called as Edmund's reagent. This Edmund reagent, it reacts with again N-terminal amino acid to form phenyl thiocarbamide, PTC, phenyl thiocarbamide derivative. Here hydrogen and this group, they reacts with each other and there is formation of PTC derivative. This PTC derivative, when it is reacted with mild acid, a cyclic compound is formed. This cyclic compound is formed, and this cyclic compound, it releases the other remaining, when this cyclic compound is formed, the remaining polypeptide chain is removed. Again it reacts with the next Edmund reagent, and in this way one by one N-terminal amino acids are removed. Edmund reagent has an advantage since a peptide can be sequentially degraded, liberating N-terminal amino acid one after another. So from that we can identify the sequence of amino acids present in the protein. Nowadays, actually this method is quite a lengthy method to identify the sequence of amino acid. Nowadays, digital sequenters are available. As soon as you put the sample, immediately you can get the sequence of the amino acid. So these are the methods which we can use to determine the primary structure of